I would like to show you a few simple rules related to header files and implementation files. So if we open our project configuration using Solution Explorer inside Visual Studio, you should remember that only source files which have extension CPP or CXX, which is another typical extension for C++ source files, or .c, which is a C compiler file, but also a source file. Only implementation files can be placed on the list of source files in your project configuration. So this is okay, and that's how it should be, because if we forget one of these files, then we won't be able to properly build our program. However, the header file, like this pingpong.h, should never go on the list of source files. Instead, the header files are always included and processed by the C++ preprocessor. They're simply the entire content of the header file is just included in every file. So the net result of include is just this. Basically, all this is replacing this. This is how include works. So the compiler gets all of this resolved before the actual build taking place. And of course, every nested include like this is also going to be resolved and replaced by the content of all of this. So by the time compiler processes our entire source file, all of the includes are completely resolved, and now there's only plain code which the compiler can process. So of course I'm going to bring back our includes, but it's just, you should realize that this is how simple the include mechanism is. It's just simply text manipulation facility that basically says, you're telling me you have a source file, and you're telling me that there's a header file that should be included here. So it starts looking for this file in the same directory where this file exists. And of course, in our case, all three files are in the same directory. So just using the include simply takes care of using this header file in our source files. Notice the difference that when we use angle brackets, it's the signal to the compiler that we're looking for a system file which is installed somewhere in the known directories after we install our compiler environment on our system. So these are system header files using the so-called angle brackets like this, right? So we use angle brackets right here, and that's what we do with system files. With our own files, which are residing somewhere in our own project directory structure, we use double quotes. So unlike angle brackets, double quotes direct compiler to look not in system libraries, but in our own project to find this file. And if we're not using any kind of directory names in front of this name, it is simply expected to be located in the same directory as the source file. Okay, so in our case, it's all easy because all three files residing in the same directory, and everything works pretty well. There is one more thing I would like to mention with respect to the header files. So it's very easy to include a header file, just extremely easy. However, it is possible that sometimes one header file includes another header file, right? It can have its own includes. And let's say that this is our own includes, also using double quotes. And this file includes another file, which is another possibility. And then it's possible that this file would want to also include this file, because it thinks that it also wants to use this include. So this is now another example of a recursion, but so it's possible to circle reference these includes like this. And the preprocessor part of the C and C++ compiler, which is invoked as a first stage of processing the source file, really has no defense against this. It will simply again run out of memory and will report that there's like poorly structured includes. So regardless whether we are anticipating something like this or not, there is this very simple rule. Every header file that you create supposed to have header guards, okay, or header guard. Okay, so this is how header guard works. Step number one, you typically I just right click on the tab inside Visual Studio and copy the full path. Okay, and I just place the whole path here, and I normally get rid of the directory path and only the name of the file retained. Okay, so now how do you create a header guard? You say if ndef, which is if not defined, something that looks like this. I take this name of the file, I press Ctrl C, copy and paste. Oops, I just hit the wrong build key. So copy and paste like this, and replace the period with underscore, then add included. And then I typically double click to select the entire name. And if you press Shift Control U, or it's also found in Edit, Advanced, and you'll see there's you can make uppercase, lowercase with these shortcuts. They're very useful shortcuts, so you should probably learn what they are. So basically Shift Control U, making stuff uppercase like I did. And then you copy and paste this one more time and say if it's not defined, define it. And finally, if and def requires and if like this at the bottom of the file. So this will be end if, and end if does not require the name, so I just keep it as a comment. So how does this work? So the idea of a header guard, which every header file should have, is such that it needs a unique name like this, which is simply, I mean, one of the methodologies to use is to simply derive this name from the name of the file itself, which is relatively unique within our project. And then can create the symbol. Normally it's all uppercase, which is a required, like it's a convention for naming preprocessor macros. And so this preprocessor part of the compiler that takes this file and inserts it in place of the include directive. Everything with the pound sign is preprocessor directive, and process before C++ compiler will work with this code. So preprocessor supports its own symbols, and you can define these symbols by using the define directive. So this will be the symbol defined right here. So let's review this one more time. So when this file is included here, preprocessor will check if ping pong is already included. And if it's not included, right, or already defined, so if it's not defined, so ndef says if it's not defined, it will define it. And these things will be removed from the file, and only this stuff will be included in place of this include. So basically like copy and paste, insert in the original source file. And the next time, if we just happen to do this multiple times like this, directly or indirectly, doesn't matter. The next time, if this source file being processed repeats this include, preprocessor will realize that this symbol is already defined by the previous include. And if it's already defined, this entire thing from here to here will collapse. Basically, it will become an empty set of lines like this. And so therefore, all subsequent includes will just collapse into empty lines. And this is the idea of the header guard, right? Essentially, by manipulating the preprocessor itself, by using this preprocessor symbol, ping pong _h included, we're controlling a way that multiple includes should be safe. In other words, if we use these multiple includes, and if we try building this program, there should be no issue, no complaints or anything. But if temporarily I get rid of this header guard and try building it again, I get an error that tells me that times to play has a redefinition. Basically, because the file is now included physically 2 times, what compiler sees is this. And in C and C++, there is a one definition rule. So you cannot define objects multiple times. You cannot declare local variables with the same name two times or 3 times. You can do it only once. And therefore, we get this times to play redefinition error because I temporarily removed the header guard but included the file twice. But if I bring back the header guard like this, right? So I just bring back this new structure and get rid of this, just do it like that, right? So now everything, so this is kind of looks malicious, but I mean, again, even in this case, the header guard should be able to collapse the content of the header file the second time we attempt to include it. So if I try building it now, it builds just fine, okay? So of course I will remove this include because I don't need it, but you get the idea. Just don't even try to doubt yourself. This remember, when you decide to create new header file, which is a great idea, you can use them very efficiently. But remember that every header file needs a header guard. And it's also a common mistake if I copy the content of this header file into another header file, it will contain the same symbol. Just remember, as you rename your files, you also have to rename this header guard macros to match, to be unique. Each header guard has to have this unique unique name used for its protection. And of course, this comment typically, is not used in the source. But you see that this is something that that is just very important. And like I mentioned, all includes are simply text processing tools. So if I go here, and if I'm able to right-click and say, go to document IO stream, if my environment allows me to do it, it doesn't. But in your environment, you may be able to do this, just like right-click and go to document, just to open this IO stream. The first thing that you will see inside this text file is just a text file without extension. You will see the header guard, I promise you. So you can try it on your system. So beyond this, this is an idea of using multiple source files, and you can see that now we have very nicely organized file with the main function, which includes the common parts of our system. Likewise, the business rules are specified. Our function definitions are found in a separate implementation file, and the header file contains declarations of our functions and also a definition of this constant string, which we use right here to display the prompts to the user.